velocity of 50 meters per second? A. What is the total time spent by the ball in the air? B. Calculate the highest distance reached. Solution. A. Final velocity v is equals to 0. A is equals to minus 10 meters per second square. And initial velocity u is equals to 50 meters per second. Using our first law of equation of motion, we have that v is equals to u plus at. Substituting the values, we now have 0 equals to 50 plus in bracket minus 10 times t. Making t the subject of the formula, we now have 50 over 10, which now gives us 5 seconds. The distance v is equals to ut plus half at squared. Therefore, the distance s is equals to 50 times 5 minus half in bracket minus 10 times 5 raised to power 2, which now gives us 125 cm. Example 7. A particle moving in a straight line with a uniform deceleration has a velocity of 40 meters per second at its point P, 20 meters per second at a point Q, and come to rest at a point R, where QR is 50 meters. Calculate I, distance PQ, II, time taken to cover PQ, III, time taken to cover PR. Looking at this diagram, figure 1.13 example show that the body is moving with a velocity of 40 meters per second at P. Then at point 20, it is moving with a velocity of 20 meters per second. Then when it is at R, it came to rest with 0 meters per second. Then we are given the distance from Q to R as 15 meters, and we are asked to get the distance from P to Q, and the time from P to Q, and the time from P to R. Solution. Using the third equation of uniform motion for equation between QR, v squared is equals to u squared plus 2ax. S is equals to QR, which is equals to 50 meters. U is equals to 20 meters per second. V is equals to 0. Substituting the values, we now have 0 squared is equals to 20 squared plus 2 times a times 50. 0 is equals to 400 plus 100a. Taking the unknown value to the left hand side and the known value to the right hand side, we have minus 100a is equals to 400. Then making a the subject of the formula, you have 400 over 100. We now have minus 4 meters per second. The negative sign indicates deceleration. Using the deceleration for motion between PQ, we have that distance PQ, using the first equation of motion, we have v squared is equals to u squared plus 2ax, but u is equals to 40 meters per second, v is equals to 20 meters per second, and a is equals to minus 4 meters per second squared. Substituting the value, we have 20 squared is equals to 40 squared plus 2 times minus 4 times PQ. 400 is equals to 1600 minus 8 PQ. Putting the values at the left hand side, known values at the left hand side, and the known values at the right hand side, we have 8 PQ is equals to 1600 minus 400. 8 PQ is now equal to 1200. PQ is equals to 1200 200 over 8, which will give us 150 meters. II for time between PQ. V is equals to U plus 80. Substituting the value, you have 20 is equals to 40 plus in bracket minus 40 minus 20 is equals to minus 40. We now have T is equals to 20 over 4 equals to 5 seconds. I. Time taken to cover PR. Taking the first equation of motion, we have that v squared, which is the final velocity, equals to initial velocity u plus acceleration times a times t. Substituting the value, putting the value, but we know that v is equals to 0 meters per second since it is at the final velocity, and u is equals to 40 meters per second. Substituting, we have that 0 is equals to 40 plus in bracket minus 40 is equals to minus 40. T is now equals to 40 over 4, which will now give us 10 seconds. Example 8. A ball has a mass of 0.2 kg and fell a distance of 30 meters. If air friction is negligible, calculate its velocity. Solution. Since the ball was dropped from a height and air friction is negligible, then kinetic energy gain equals the potential energy loss. Kinetic energy gained is in bracket half mv squared, which is equal to minus loss in potential energy, which is mgh. Half mv squared is equals to mgh, but mgh is equals to 0.2 times 10 times 30, which is 20 joules. Half mv squared is equals to half times 0.2 times v squared, which is equals to 60 joules. Making the final velocity the subject of the formula, we have v squared is equals to 60 all over half times 0.2, which will give us 600. V squared, letting the square root crossing the equality sign, we have the square root of 600, which will now give us 24.5 meters per second. Example 9. A body at rest is given an initial uniform acceleration of 0.8 meters per second for 30 seconds, with the acceleration is reduced to 5.0 meters per second squared for the next 20 seconds. The body maintains the speed attained for 60 seconds, after which it is brought to rest in 20 seconds. Draw the velocity time graph of the motion using the information given above. B. Using the graph, calculate I, the maximum speed attained during the motion, II, average retardation as the body is being brought to rest, III, the total distance traveled during the first 50 seconds, IV, average speed during the same interval as in II. Solution.